Guys, once again, we arrived at this crazy problem, boring problem from the book. Okay, so we're about to solve this one. It has no answer here, and we will try to answer it. So we find out that there is a girl lifting weights through a pulley. So how do we solve this? It says here an athlete pulls a handle A. Okay, handle A to the left, okay, with a constant velocity of 0.5 meter per second. Okay, if we are, I'm going to break this down, okay? So, imagination, okay, I'm going to put an imagination here. If I'm imagining this, if the girl is pulling point A or the rope at the point, yes, it is. If it's pulling point A, okay, or particle A, expect that the rope is being pulled, of course. The weight B is going upwards. There are only 2 points here, A and B. So the particle B is going upwards if the girl is pulling it leftward. Okay? That is my imagination. If A is going leftwards, then B is going upwards. You see, alright? But assume that the end of the rope is fixed. I mean is that this one here is not increasing in length, because this gym equipment will be useless if the weight B is going upward. Then how's this? It's getting pulled away. Of course, this will fall down. It will not rise up if this end of the rope is not fixed. It must be fixed. That's according to imagination. It must be fixed so that B will be able to go upwards. Right, so how do we solve it? A. Determine the velocity of the weight. Then the relative velocity. Velocity of the weight. Velocity of the weight. No, I'm going to put a solution here. Okay, that's it. So, how the Carabao? We need to generate an equation again based on the rope length condition. Okay, so generate an equation based on the rope length condition. Okay, so how the Carabao? You need to start from point A. If you see, if point A is going leftward, expect that the length of this inside the box, the length of this above B is changing in length. But of course, the rope, the total length of the rope will still remain the same. Okay, it's constant. So we must neglect the constant pulley length. Also, the length of this from point A, the length of point A from this pulley is important, but we must ignore this vertical length of the rope, then this horizontal length of the rope, then the vertical length of this rope. Oh, no, actually this one we will consider. If we notice a change in length, we must consider that if B is going upward, the length of this rope is changing. The length of this rope also this one, and this one is changing. And they are very important. But for this one here, ignore them because they will still remain constant even if A and B are moving. If they are moving, this length here is useless. This length here is still useless because it's still the same. This one too, at the end point, is still the same. It would never change. Only this one. This one is changing because B is going upward while A is going leftward. Okay. So how do I generate it? X sub A, okay, plus, okay, I'm going to consider X sub A, the length of A from where? From this one? Yeah, we can actually use it. The length of A, okay, intuitively, it's just the length of A from this one, neglecting the constant length of the rope. You know, just reckoning from, let's say, from this wall, X sub A plus X sub B. Okay, this one, X sub B. Because I neglected the constant lengths from this outside the box. So I immediately jumped up to X sub B. Because the rope at this point is changing because of B. Because of B, it is changing. That's why I put X sub B. And another one, the next rope here, we will still call it X sub B because it is changing. Because of B. And it doesn't matter if we are reckoning our rope length from the ceiling again. The important is they are changing in length. That's why we call it X sub B. Even if they move, their location from any reference point will still be the same, X sub B. And another one, next X sub B. Another one, X sub B again. Because there are four. 1, 2, 3, 4. Neglect this last stage of the rope, okay? Then equals to constant. So if you add them, even if they move, even if B is already in the mid-air, the total length of the rope will still be the same. So it's constant. Okay, and if you summarize, you will have 4. And then, if you differentiate this equation, expect the constant to be 0, and this one to be V, and this one to be V. Alright, so what we are looking for here is the velocity of the weight B. So we need to isolate V. VB. If we transpose VA, we will have VA, but it will divided by 4 negative. Okay, that's it. And I think VA is given. Yes, VA is 0.5 meter per second, and its direction is not necessary for now. We just know that it is 0.5 meter per second. So if we divide that, 0.5 times 2 times 2, okay, so 1 over 8. What's 1 over 8? I will just put it here, 1 over 8. Okay, 1 over 8, and neglect the, yeah, that's it. One over 8 meter per second. And its direction if we are pulling A, expect that B is going upward. This is going leftward, then B is going upward. So what does that mean? Even if it's negative, even if it's not negative, it's obviously upward, guys. How about the relative velocity of weight B with respect to the handle A? Okay, it is very easy. Weight B over with respect to A. So VB minus VA. That's it. So our VB is 1/8 minus 0.5. What's the fraction? What's the decimal form of 1/8, guys? Okay, wait, guys. I'm going to find a calculator because I'm very weak at calculating fractions. 0.8 divided by no 1 divided by 8, 0.125. Okay, so it's actually 0.125, and so if we add that minus 0.5, uy, negative 0.375, negative 0.375 meter per second. Or if we include its direction, what is its direction? Because since it's negative, wait, actually this is a very important situation. That's why I included it here. As you see, I already told you on my last video that the relative velocity of two values, if they are not the same in direction, is that you need to get the difference, the vector difference of the two. So since leftward versus vertical, horizontal versus vertical, leftward and upward, you need to get the hypotenuse. So the V with respect, the velocity of V with respect to A is equals to the hypotenuse of VB squared plus VC A pala 2. Yeah, that's enough. Zero point 125 then. Okay. So how we need to use the emulator? Square root 0.125 0.5154. Okay, so that is our relative velocity for leftward and upward. Yeah, that's it. And then their angle is the angle of B with respect to A is equals to tangent raised to -1. Then of course it's TOA, opposite over adjacent, or upward over leftward. That is 0.5 over 0.125. shift tangent 0.5 over 75.96. So, am I correct? So, I think we only need A and B. Let's check our answers. Ano to? 11.49. So 11.49, 0.5154. Our A is 0.125. So A is 0.125, okay? 1.8 is 0.125 upward, then this one VBA is what? 11.49, 0.125, but the angle is, I committed a mistake here. It's not the same with the answer key. But of course, if we have a leftward arrow, then upward, if you get the hypotenuse distance of the two, you need to opposite over adjacent. So our opposite is upward, right? So actually, it's wrong. Our opposite should be the upward, and that is our V sub B. If that is the V sub B, and then our V sub A, which is the adjacent, 0.5. So we need to recalculate it. Divided by 0.5, so 14.04. That's it. So all goods. Thank you for watching again.